All right, so I am going to go to our quiz here. And where were we? We were going to do an inner join between customer and the other one. So let's use Sequila, run that. And then we were looking at customer, select everything from customer. Perfect. All right, so in customer, we have this address ID, and it's the foreign key to the address table. And what's cool is in a lot of these IDs, we can actually, it recognizes that it's a foreign key. And you'll notice that it has these little like arrow things. This is one of the things I really like about dbeaver is I can actually click on this. So for example, Jennifer Davis is connected to address ID 10. So if I click on this, it actually takes me to that address, which is essentially the same thing that we're going to do just with code to kind of bring that all out. Basically, we're going to take the key and we're going to use it to kind of pull our additional columns that we want to bring over. So let's walk through that real quick. And I know this is there on the code kind of there for you, but I kind of want to walk through it to kind of show you what I like to do as best practice, because if we go back to the exercise, you'll notice that they actually have 3 joins. We're going to end up going all the way to city, but I'm not going to worry about that right now because I like to take joins one at a time to test the results. So I'm going to start with everything from customer C, and I'm going to inner join that against address A. And we kind of know exactly which way we want to go, because if we're in customer, I kind of like to think about it as like going through doors. Like to get to certain information, sometimes we have to chain a couple tables together to get to where we want to go. So in this case, in customer, we really only have 2 directions we can go. We can either go to store or we can go to address. And in this case, we want to, we want to go to address, and eventually we'll get to city because we want the address of the customer, which is what this address ID does. Technically, we could get to address through the store and then through address, but then that would be the address of the store. And just to talk through this a little bit, the inner join, I don't know, again, if in the announcements you saw the Venn diagram I sent, but I like to always think of joins as these Venn diagrams. And I'm just going to pull this up here real quick. If you Google SQL joins,
so the browser's gone again. It's just black. Just
okay,
so
let me try a different browser. We will just try a different one. Can you see this one?
Yeah, that's working.
Okay, perfect. All right, so this is probably one of my favorite little cheat sheets for joins, is this little diagram thing. And that one's not a super high res quality version. So let me see if we can find a better one here. Sounds a little weird as well. There we go. Yeah, that one's small too. We'll use this one. There we go. Okay, perfect. So basically, think whenever we join something together, we're really taking 2 data sets and kind of gluing them horizontally. We're adding columns. So basically on where we're doing an inner join, table A is going to be customer and table B is going to be address. And because we want to get, basically because we're saying we want an inner join, we only want customers that have addresses is essentially what we're saying. So if a customer doesn't have an address, they're going to be over here on this side of the Venn diagram and they won't be included. Only the highlighted portions are included with the type of join. So something you got to think about whenever we're joining data, you got to think, okay, do I want all the results on the left, all the results on the right, or just the ones that have matches? And some of those things may vary on business use. So for example, if we are sending out Christmas cards or some sort of mailer marketing promotion thing, we probably want to use inner join because we don't care about customers who don't have an address. But maybe we were looking for people who don't have an address because we want to call them and update their information. Then we would probably do something a little different, like a left join, which we'll go over in a little bit. But the most important part of any join is the on clause. So we basically say we want to go customer C inner join address A, but we got to tell it what we want it to match on. Because even though like dbeaver might know, we might want to join on different things, as you'll come across, so that we can join on all sorts of things. So we want to tell it exactly how we want to match rows together, because we're going to take and add the address columns on the side, but the data within, we want to make sure that Patricia Johnson's address belongs to her. So how we do that is we kind of exactly how when we clicked on this before, we got the same information. So for example, we want Patricia Johnson in the customer table's address ID to match the address ID of the address table. So we kind of just write that out. Customer.address ID is equal to address.address ID. So now if we run this, we can see that we have Patricia Johnson, address ID 6, and this is the address ID, address ID, which is 6. So they match because that's what we told it to do. And so we know that that's her address. So once we get to this point, we kind of know that we have everything we want. From this join, now we're going to take it and we're going to join to city. So what I'm going to do is I'm actually going to real quick just take a look at what's in city. And in city, we have a city ID, country ID, and I'm guessing in address, we have a city ID. And there it is, city ID. So we know what we're going to join on. We're going to go from address to city. So let's do another inner join on city. And I'm just going to call this one CTY. And we're going to do it on a.cityid is equal to cty.cityid. So same thing. And just to walk through our Venn diagram again, because this time it's a little different. We're not going from address necessarily to city. We're really going from the combination of customer and address. So once we join data together, the next join is actually a join on both of those. Now we can do multiple matches because sometimes like you might have to match against both the previous tables, but really once we join, that kind of part of the from clause is now considered a single data set. So really this is now what A is, and this is B. So now we're going to go from there to city, and let's go ahead and run that. And now we have a lot of columns available to us, including the city. So now we have all of our columns available to us, and we can then select what we want to see, which is in the instructions, we want to see the C.first name, C.last name. We want to see the address. And finally, the city. And there we go. Now in the example, there is one additional kind of, it just has a where clause attached to it, and it says where a.district is equal to California. So this is our result set here. 9 people. Let me hurry and get this in my other browser here. Does that all make sense to everybody though? The kind of that walk through the joins. Anyone completely lost as to what was going on there? And that is completely okay if you are.
When you have the from customer C and then the address A, is the initial, is it okay to just think of that as a alias?
Yep. Yeah. In fact, that's exactly what they're called. So the C and the A are called table aliases. And really it's the same thing. We could exactly kind of mimic this. So I'm just going to copy this. And if I were to take all these off, we could do the same thing. It just involves more typing.
You're black to black. You're back to black again.
Interesting. How about now?
Same.
Yeah, that's black. We could see what was behind it though. Yeah, that one. We can see that one.
Okay, just not this one.
Correct.
Okay. Maybe it's been this one all along. Let's try workbench here. Okay, so I'm going to take, basically, I'm going to take the aliases off of this one. So I'm going to take customer off and city. And basically what we have to do instead is just write the whole name of the table. So really it's the alias is just like a type saver. We can just go contact, address, city, and address. So we should end up with the same result as long as I didn't miss anything here. Unknown, oh, contact, sorry, customer. So let's try that. And apparently I need to learn how to spell. There, okay. So the same thing, but yeah, just those table aliases are just shortcuts, just like we can alias a column. We can do the same thing with the table, but really at the table level, it's more to just save some typing. Now, when we get to the point where we're doing subqueries, then we have to use an alias when we put a subquery in the from clause, which we'll talk about when we get to subqueries. All right, let's go to here. Let's take a look at this exercise again. So we can kind of see from this, so for example, what we would put here is, you know, city ID or whatever your alias is. So ct.cityid. And on the address one, it would be A. So one would be A and two would be ct.cityid. So nothing too crazy there. All right, so write a query that returns the title of every film in which an actor with the first name John appeared. So this one's kind of like a fun one where we just start basically finding every film that has John in it, a John in it. So I'm going to delete this and we're going to start off with film. So I always kind of like to start and just kind of work my way up, especially when we're joining data together. All right, so we're in film here and we want all of the films that have a John in it. So I'm going to go from film to probably film actor. So let's see what's in film actor. Because that's probably where we can find what actors we're going to film. Now, this is again where we kind of get to think a little bit about our use case. So from film to film actor, do we want to use an inner join or a left join? Basically, do we want to include all the films regardless of whether they have an actor or not? Because maybe there are films that don't have an actor. You know, maybe like a silent documentary or something. In this case, because we're looking for all the films with John in them, I'm going to say that we can feel safe doing an inner join. So I'm going to say inner join film actor, and we're going to call that one FA and this one F. And again, we need to tell it what we want to match on. So we go from film ID to film ID. All right, so now we have all of our films and we're connected to this film ID, but you'll notice we don't have any actor information. And the reason why there's this in-between table is because films can have multiple actors and actors can be in multiple films. So it's kind of like a way to kind of get a many-to-many relationship, but while staying normalized, because really there's this table in the middle that kind of holds the combination of the two. So from here, what we need to do is we need to go from here to an actor. So actor A, and we're going to go on actor ID is equal to A dot actor ID to get to our actor information. All right, so now we have all of our actor information. You can see now we have actor ID, first name, last name, yada, yada. So now what we want to do is let's take and filter this down because we only wanted to see the films where A dot first name is equal to John. So here's our list of films that have a John in them. And then let's clean up our results just a little bit. So it says that it wants the title of every film. I'm going to take it a little step further and never be afraid to do this because it's not going to hurt your score. In fact, we like to see it to think a little bit. So I'm actually going to not only get just a list of titles like this, I kind of want to see like what Johns are in there. So I'm actually going to get A dot let's get A dot first name and A dot last name. Because I was kind of curious if these are all the same John, which it looks like they are. So it looks like all these Johns are the exact same actor, which is kind of what I was curious about. So so I'm going to keep mine like that, but yeah, essentially that is question 2. All right, so it says construct a query that returns all addresses that are in the same city. You will need to join the address table to itself. So this is kind of an interesting concept. So when we think of a table, we can also make copies of the table or use it against itself, which we'll show you in just a minute. And it says in each row should include 2 different addresses. So essentially what it's saying here is we don't want to see a row with 2 of the same addresses, which we'll talk about here in just a minute as to why that is, something we want to see. And this one always kind of gets people hung up a little bit because really what we're doing is we want to see basically, because it says we want a list of addresses that are in the same city. But really what we're wanting to do is see like, okay, here's this address. What are all the addresses that are in the same city as it? And then on to the next one with the same story. What are the same addresses in the same city as it for all of our addresses, which is just kind of crazy, but that's what it wants. So what we're going to do is we are going to start off by selecting everything from address, just like we did before. And we know that city, we want to see the same cities. Now, technically, we could get this just by using itself, which I'm going to do right now. So what I'm going to do is I'm going to call this A1. So basically, if I ever have to do what's called a self join, like we're going to do, I just give it an alias of A1, which is another time when aliases are kind of required, because if we put 2 addresses, it's going to be a problem. So we're going to take address A1 and we're going to join that against another copy of address. And I'm going to call this one A2. Right. Okay, so now we're here. And now what we want to do is I want to say on, and this is where we have to kind of say, oh, we want it where they're in the same city. I'm going to say where address 1 city ID is equal to address 2 city ID. Now, if we run this, we're going to have a lot of information. So just to start off, I'm just going to do A1.address ID, A1.city ID, and then I'm going to do A2.address ID and A2.city ID, just so we can kind of make sure we're getting the same stuff. And I'm going to just give these aliases: A1 address, A1 city, A2 address, A2 city. And I'm going to give those aliases so we can see which one's which without being too confused. All right, so if we take a look at this, here is our address IDs and our city IDs. Now, remember, the big kind of key to this is we don't want to see a line item with 2 of the same addresses like we see here, because obviously if the same we're comparing the same list against each other, they are, it's going to appear twice, and meaning that it's obviously in the same city because it's the same record. And we want to exclude these. So basically we can do this one of two ways. We can add a where clause to say where a1.cityid does not equal, or sorry, a1.addressid does not equal a2.addressid. Now you can see that we're not matching anymore. Or we can add it to our join clause, which is what I'm going to do. So I'm going to say where, and so this is join condition 1, but I'm going to say and a1.addressid does not equal a2.addressid. And you'll notice we get the same results, just this one has it in the from clause versus in the where clause. So feel free to do it however you want, but I just wanted to show you how you can do that in the join, which I kind of like because that way it leaves the where clause to kind of do normal sort of filtering. Now I'm going to take this one more step because this is cool, but it doesn't really mean much. And so what I'm going to do is I'm actually going to join this to city. Now, one thing about this is we kind of have two addresses here, right? So I can't really say on like, I actually have to join city twice. So I'm going to say on a1.cityid is equal to, oh, and this was supposed to be a C1 here, c1.cityid. Now what I can do is up here, I can say c1.city. And we can see now that this is Aurora. Now, technically, this one's going to be the same, but just for the sake of showing you how we would do this, we would say interjoin city C2 on a2.cityid. Technically, it doesn't matter, but we're going to keep things good here, clean, equals c2.cityid. And now we can come up here and say c2.cityid as c2 city. And not city ID, we want just the city. There we go. And so now you can see that we have the cities kind of there, which address and so on and so forth. So does that make sense to everybody what we kind of did here with the self join? Basically imagine like taking another copy of it. It's really great for comparing. All the time we have to compare a table against itself. And this is a really nice way to do it. Does anyone have any questions about that so far? All right, that is question 3. All right. This one, question 4, is write a query that shows all the films starring Joe Swank that have a length between 90 and 120 minutes. I'm going to leave that one up to you guys because nothing too new there. Really, it's just joins like we've done, but with a where clause. But this one I wanted to go over because we haven't talked a lot about aggregation previously. So I mean, we've talked about it, but I want to go over this one. So we want to write a query that shows how many rentals are associated with each of the 2 staff members. And it says it should display the following data set. So basically we want to know, this is kind of like an overall performance, like how many rentals have gone through each of our staff. So this is a pretty common thing that that probably happens in real life. So again, we're going to start off with our staff. I kind of always like to start at the root of the data. So we're going to start with staff, and here's our 2 people. So we have Mike Hillier and John Stevens. John spelled Jon. So let's take there's our staff. And now what we want to do is we want to see how many rentals have gone through there. So what I'm going to do is I'm going to select everything from rental and just see what's available to us there. And if we look at this, we have, what do you know? Staff ID, which is perfect, which means we don't have to do anything other than a singular join. So when we join to our rentals, I'm going to do a left join on this one because What if we had a staff member that had 0 rentals to his name? We would still probably want to see that, right? Because if we had a staff member who didn't have any rentals and we did an inner join, it's going to completely exclude him from the results. Like he just won't even show up. So we actually want to see it. So let's left join to rental R on s.staff ID is equal to r.staff ID. Now this is going to return a lot of results because we have a lot of rentals. And so you're going to see like Mike Hillier's data is being duplicated a lot, which isn't very helpful to us, you know, in bulk like that, if we're trying to summarize things. So this is where we get to do what's called aggregation. So we want to basically take multiple rows and we want to perform some sort of formula on them to condense it down into a summary or an aggregation of the data. So aggregate functions could be something like sum. It could be like the count of how many rentals, all that kind of stuff. So let's start with the question here at hand, and we want to get the staff first name and the staff last name. And then to get our kind of count, what we want to do is we want to use the count function, which is an aggregate function, because we're going to count things and we're going to count the rental ID from rental because that will count unique number of rentals. And we're going to call it as total rentals. Now, if I were to take and run this, it's actually going to throw an error. And the error is, I know it's hard to see, it says in an aggregated query without a group by. So basically it says, hey, like you can't do this because you haven't told me how you want to group this. So basically what we do is we just say group by, and we can actually just add the first and last name because we want counts by our staff's first and last names. So if we run this now, there we go. We get our staff total counts here. So there's that. Oh, go ahead.
Yeah, sorry, just one question about that total rentals. That total rentals is like a variable, like an imaginary column that we are creating to, or is that a column of the table? Like I just didn't realize.
Yeah, so it's basically a variable we're creating.
Okay, it's just like temporary.
Yep. So if we were to go through, so if we were to take that off and just leave it like this, and then just do our rental ID. So if we were to do this, it's pretty much like us going through and saying 1, 2, 3, 4, 5, 6, 7, 8, 9, down and down for all of Mike. And then once we counted up all of Mike's, we would then start with all of John's. So basically it's a count of all the unique rentals. So like how many rentals do they have with their name attached to it? So like in this case, Mike Hillier has had 8,040 total rentals, which is 36 more than John, who only had 8,004.
Oh, okay, got it. Thanks.
Yep. And so just as another example on the aggregate, so if we take a look at rental again, there should be a select everything from rental. What did I typo here? Oh, it just wants this. There we go. So if we take a look here, inside of rental, we have, so like, let's say we want to add another metric to this, and we want to see not only who had the most rentals, but we want to know how much money in total, how much revenue was brought through each staff member. Because, you know, this is pretty close, 36 rentals. Let's see if maybe John, despite not having as many rentals to his name, maybe he outperformed in talking people up to new releases or something like that. Not that it's a competition. You only have 2 staff members, take them both out for dinner. They both performed well, but let's just take a look. So inside of our database, we have this payment table. Let's take a look at this payment So inside of our payment table, you'll notice that we have a rental ID. So what I'm going to do is I'm going to left join again, because again, if we do an inner join, we're going to exclude any staff who don't have a rental and subsequently don't have any payments come through. So I'm going to left join payment P on r dot rental ID is equal to P dot rental ID. All right, and since we already kind of have this here, all I have to do, since we're doing the same kind of aggregation level, is I'm going to take the sum of P dot amount as total revenue. So now if we take a look, let's see who came out on top, and what do you know? It actually does look like John. He brought in $33,881, while Mike, who had more rentals, brought in $33,524. So again, like that's just taking all of our payments and summing those up, because we can see exactly what the payments were on this. So let's just do that again so we can kind of see the raw data here. P dot amount. So this is, while we count this row, we count just how many there are. In this one, we're taking the sum, we're adding this. So 299 plus 299 plus 399, just like in Excel, if we were to take the sum of that column, that's essentially what we're doing with the sum function to get the total revenue. And then from there, if we wanted to, we could say, okay, what was, since that's interesting, right? Like someone had more rentals, but less revenue. Let's say we wanted to see, oh, what was your average revenue per rental? So we're going to take the sum of P dot amount, and we're going to divide it by the count of R dot rental ID. We're going to call that average rev per, let's just do, let's just call it rev per rental, RPR. Revenue per rental. Yeah. It's a nice little KPI. And there we go. And so now we can really see kind of what the total kind of implication here is. So looking at this, John kind of barely wins by a hair because his average rental was $4.23. Meanwhile, Mike Hillier's comes out to be, you know, rounding $4.17.
Nice.
Well, anyways, that's question 5. And honestly, aggregations are kind of like my favorite thing, because like that's kind of the whole point is once we have our data, we want to use it. But raw data in itself can be interesting, but sometimes we want to see, you know, macro level to find out like, you know, like what's going on. Because, you know, for us to be able to, you know, say, oh, what's going on behind our staff, which really there's not much, but, you know, it is interesting, you know, that Mike Hillier had more rentals, but less revenue. We would never have been able to find that without the aggregation. And that is question 5. And we took question 5 a little bit further than we needed to, which is fun. Any questions on the exercises before we roll into some other things? Okay, real quick before we jump into final project type stuff, I wanted to go over a cross join, and which is really not too complicated, but really a cross join is let's do a cross join and a subquery all in one. So let's say that we wanted, and this is called data fabrication, which we're going to cover in an upcoming week. So we're getting a little bit of a head start, but it's honestly the easiest way to show this. So let's say we wanted to come up with a way to find all the possible combinations of spinning some dice. So we know a dice, and I'm not going to do the big 20-sided ones. We're just going to do a normal 6-sided die. So basically I'm going to get the total possible outcomes for a single die. So what I'm going to do is I'm going to select 1, union, select 2. I'm going to go ahead and hit this. And you can see that I'm kind of adding some rows here. And we haven't covered what a union is yet, but just so you know, we're just adding rows. So I'm going to select union, select, and let's just go like this. 4, 5, and 6. All right, so here is all the possibilities of one kind of die. So what I'm going to do is I'm going to give this an alias as, we'll call it dice 1. And so there's the sides of our dice here. So now what we want to do is we want to add another dice and come up with every possible combination. And we know that the total of every possible combination is 6 times 6, right? So 36 total combinations if we have two dice. So what we want to do is we want to kind of mimic that effect to kind of get our total possible. And the way we do that is with a cross join. So what I'm going to do is I'm actually going to put this in parentheses, so it's a subquery. So I'm just going to put you in parentheses, and I'm going to give this, just like we talked about before when someone brought up, I can't remember who brought up the aliases. I'm going to give it an alias. I'm just going to call it dice 1. Actually, let's just call it D1, just for being short. So D1, just like we normally would do our little tables here. So I'm just going to select everything from D1, right? So let's just select everything from D1 again. Same result, just like we normally would. So basically think of this subquery as a table itself, right? It basically is acting as a table at this point. Because remember, any select statement is going to return a table. It's just a virtual one. So we're selecting this virtual table and we're calling it D1. And then we're going to take and cross join that with basically the same thing. So we're going to cross join this with another subquery, but we're going to call this one D2. So now what we're doing is we're getting everything from dice 1. We're going to call this as dice 2. And what is missing here? What did I miss here? Oh, guess I got to put things in the right order here. Cross join. There we go. So now if we go ahead and run this, you'll notice that we get like all of our possible combinations, 36 total rows, but they're out of order. So let's go ahead and order those. So I'm just going to say order by dice 1 and then by dice 2. So now we can see that, oh, for every 1 I roll on dice 1, I'll roll 1, 2, 3, 4, 5, 6 on the other dice. Total possible combinations. Right. So like, let's say that we kind of wanted to build like a game, right? Like a virtual game. This is kind of a really nice way that you, because every time, oh, for the longest time, like even when I was learning, I'm like, what is a cross join used for? Like, why would I ever want to multiply 2 tables? Like, because if you think about it, like if I had, customers and addresses, why would I ever want to multiply every customer by every address, which is true. But really cross joins become really, really handy when we kind of want to fabricate data or come up with like every possible combination and that kind of thing. And the other thing that's interesting is really like when we do our joins, before you might see questions about this, before they kind of refine this process, there's kind of 2 different kinds of SQL. There's ANSI 92, which is kind of what we've been talking about, but the older kind is ANSI 89. And really what ANSI 89 was doing, it was doing cross joins. So if I select everything from customer C join address A, I'm just going to go ahead and hit this, and you'll notice that it gives us our results, but it's doing a cross join. So if we do a plain just join, it does a cross join. And then what we had to do, if I try to put a where clause on here, where C dot customer ID is or address ID, sorry. Address ID is equal to A dot address ID. We can kind of, that kind of is what does the filtering. But before this was supported, really it was just a where clause, where C dot customer ID is equal to A dot, and I always do that, a C dot address ID is equal to A dot address ID. So really, no matter how we write it, it achieves the same result. But this is actually how they used to do it back in the old days. In fact, it used to actually be done with commas like that. So if you ever hear ANSI 89, just know that it's doing this. Now, real quick, I just want to talk to you why they made the change. So the main reason why they made the change goes back to our conversation that we had a couple weeks ago when we talked about the order of operations within a select statement. So we know that the from clause is always executed first. And whenever we execute this information, you got to remember that it has to hold all this information in memory of some sorts, you know, to the best of its ability. So basically, if we were to take a table with, you know, 128 million rows and multiply it by another table with 128 million rows, you're talking about a lot of data. You know, 128 million times 128 million, that's a lot of information. And that happens first. The from clause has to happen first. So basically, you know, obviously, as you know, the technology progressed, people really came to the realization that, hey, you know, this is expensive. Is there any way we could make this less expensive? And the way they did that was by kind of saying, well, what if we put the filter in the from clause? And, you know, I don't honestly, I mean, I can't see the source. I mean, I could see the source code of MySQL, but I've never gone through to look. But really what's happening is while it's joining, it's filtering out rows. So instead of multiplying and then reducing, it's just filtering while it's going. So that way, you know, step one, it doesn't have to multiply everything and then filter. It can just kind of get what's needed pre-matched. All right, so there's that. Let's switch gears a little bit. Does anyone have any questions on joins before I swap here? All right. So last time we talked about building these tables, but the one thing we didn't talk about that I wanted to, because we run out of time, is what we do from this point, because some of you have already sent me your diagrams. They're looking great. So, you know, we're going to be getting to this point, especially those people who kind of want to be a couple weeks ahead. So once we kind of get our diagram built, and if you haven't seen us put together and you want to see, I highly recommend go back to last week. So that would be week 3 and check out the recording. That's kind of when we build this. But once we get to this point, we can actually do something really cool where we actually just let the computer kind of build it for us. So I'm going to go up here to tools, or sorry, database. And I'm going to use this forward engineer. And what this is going to do is it's going to actually build this for us. And it's going to give us a couple options. I kind of want to go over these options here because they are important. So it says skip creation of foreign keys. No. Generate create separate current. No. Generate insert statements. No. There's a couple things here. We can ignore these. Really this one, this code generation, this is probably the most important. So it says drop objects before each create object. I'm going to highly recommend you check that, because it's going to basically make it so we can rerun this script over and over and over again, which I'll show you here in just a minute. The other option is this generate drop schema. I'm going to leave that unchecked because I actually am going to use a second option, which says omit schema qualifier in object names. And it says generate use statements. I'm going to leave that off as well. And include model attached scripts. We're going to leave that. It's there. So basically, I just like those two options. So I'm going to hit next. And this is where we actually type in our password to connect to our database. Because here we can kind of tell it to export certain things. So in this case, I've only built tables, so it's just going to export the tables. But what's cool here is now I have this script that actually creates everything I've done here. So what I'm going to do is I'm going to copy this to clipboard, but I'm also going to save it to a file. And let's just put on my desktop, actually, documents right here in samples and in the family cookbook. I'm going to put it right here, and I'm going to call it init schema.sql. And basically, I call it init schema because it's creating the schema for me for this database. And actually, instead of calling it init, I'm going to call it family cookbook schema. There we go. And I'm actually going to hit next here. And it is going to, actually, you know what? I'm not going to hit next. So I'm actually just at this point going to say cancel. Because at this point, it hasn't created anything for me. Because I kind of want to do it manually. So I'm going to say, let's open a new SQL editor here. And I'm going to paste that file in here. But what I'm going to do off the bat, so if I look here in my database, I have a few things, but I don't have a database for this. So what I'm going to do is I'm going to say create database family cookbook. There we go. So family cookbook is now the database. So if I were to refresh this, now you'll see that there's this family cookbook here, but it doesn't have any tables. So once I've created that, I can go ahead and delete it. But now what I'm going to do is I'm going to put use family cookbook. And this time I'm actually going to execute this whole script here. So let's go ahead. And it is going to basically run through the whole thing. So now if I refresh this, you'll see now that I have all my tables here, which is pretty neat. I'm going to go ahead and run it again. And you'll notice that, let's refresh. It is all still there, no errors, whatever. So let's say I wanted to change this email to email, or not email. Let's say I want to change first name to first name. Let's say I just have a typo, just like that. All right. I can run this. And if I refresh, if I look inside my system user table columns, you'll notice, oh, I have a typo. I can just come in here and edit this script really fast and then go ahead and run it, the whole thing again. Refresh, and I am back to normal. So this is really handy. Once you kind of have it built, it's really handy because I'm going to actually show you, because I'm actually going to put some data in here. Once we start putting data in here, we're not going to want to change it all that much. So now that it's here, I'm going to do one more thing before we kind of move on. The reason why I like to save this as a script is because it can become really handy. Let's say I want to create a database. Family cookbook dev, right? Let's say we want to test out a new kind of thing, you know, because once we have data in our tables, we can't just delete things and recreate them without losing data unless we, you know, script all of our data inserts. But especially once we go to production, we don't want like users to just lose all their stuff, right? So So that's why I created this second database. And let's refresh, because now we have this family cookbook dev. And so now once that extra database is created, I only have to change one line of code here. And now all of a sudden, my database is very handily replicated across both. Just one might have data and one's kind of more of like a dev kind of an instance. So anyways, that's really handy. So that's kind of why I like to use those. Once you kind of have your script, let's, I'm going to open up another one here. This is kind of where we start getting into the deliverables. So we need test cases for all these and CRUD statements for all these, which are kind of the same thing. I kind of think of them the same thing, even though it kind of lists them both. Really, we need both. So what I'm going to do is I'm going to start with the C of CRUD, which is create. And that means we're going to insert records. So the first thing I'm going to do is I'm going to insert into system user. And what am I inserting into system user? Well, I'm inserting an email, password, created at, I hope has a default. First name and last name. Last name, there we go. And then I insert some values. So in this case, let's do frodo@baggins.com. Now, normally this would be encrypted, but obviously we're just kind of messing around here. So rings aren't cool. Now, if you ever need to put I'm going to avoid parentheses, but you can always double quote something to put in an actual quote. And then this is Frodo Baggins. Now I'm actually going to insert a couple here. Technically, you really only need one. One per table is going to be fine. But I'm going to put in two here. Samwise@shire.com. Mordor's hot. First password. Samwise BMG. I'm not sure if that's how you spell it, but we're going with it. All right, so now I insert it into system user. Oh, and I forgot to kind of put a comment here. So that how I would kind of organize this is I would say, this is system user CRUD. System user. There we go. We can see our two system users there, Frodo and Samwise. Just to kind of finish off some of our stuff here, I'm going to do an update. So let's just we'll just make a fake one. So we're just going to update a password, update system user, set password equal to, and this can just be like whatever. And we're going to just say our user ID. Let's do email, where email is equal to, and we're going to update Frodo. In my database, basically, instead of having like a username, email is kind of your username. It's unique. So really, email is a good way to kind of update things. So we can run that. And so now if we were to check, now his password is Hope from Mordor. So there's the U of our CRUD statement. And finally, the delete. This is kind of some of my CRUD statements here. Now, one thing that I'm going to recommend, you can leave your CRUD statements like this, but I'm also going to kind of create what's called a seed file. And I'm going to call this family cookbook seed.sql. This script will seed data into the seed sample data. Then kind of what you can do is you can kind of, as you go through, because what we might want to do is we might want to insert into many of our tables. I'm actually going to save this one and we're going to call it family cookbook _ seed.sql. There it is. And the reason being is because then we can kind of clear out all of our data. Now, the other file you might want to have is a truncate. So family cookbook truncate.sql. Basically what this is going to do is it's just going to delete all of the data, not the actual structures. So I'm just going to truncate system user. So if I were to do this, and what does it complain about? Basically, it's complaining that I can't delete data because it has a foreign key, which there's a way to force that. MySQL force truncate. Or turn it off. All right, so let's do this. We're going to set foreign key checks equal to 0. There we go. And then after the end, we'll turn it back on so we don't ruin anything. All right, so basically we would go through and truncate all of our data actually in reverse order. So let's go ahead and add another one. So we have our system user, and let's take a look at our model here. So our system user is kind of like a root because things connect to it. So let's create a family and a family member real quick. So let's go to our seed file. Insert into family, and what do we have in a family? We have family ID, which is going to auto-generate name and owner user ID. Nice and simple. We're going to call it Gamgee House, kind of whatever they want to name it. And the owner, we're going to make this nice and dynamic. We're going to select this user ID. I think user ID. Yep, select user ID from system user, where email is equal to samwise@shire.com. I'm going to create 2 users, but I'm only going to create 1 family for right now. And now that I've added some data into family, I'm going to come back here and truncate family. And truncate basically means delete it all, but don't log it. So you won't be able to undo any of this, but it's all sample data. And that's why we're saving it all in a script so that we don't have to kind of worry about it. So I'm going to save this one too. Save script as family cookbook truncate. All right. I'm going to save this one too. Save script as. I'm just going to call this one CRUD just because it's just going to be something that we submit, which we're not going to. Just as I would do it, I would kind of keep it organized. So now that I had an insert for here, I'm going to do family. And this is the C for create. Bam. So that one's done. So you can kind of see how, even though there's a few different deliverables, a lot of this is going to kind of overlap. So let's add Sam into the family with a family member. And if we take a look at family member, we have, again, pretty simple. I like it. Family user ID and family ID. And again, we're going to kind of use some of this stuff. Oh, and any kind of thing you do here, you'll notice if we go back to our CRUD, like we kind of already had this, but if you come across them, just throw it in your CRUD statements because it's not going to hurt anything and you're probably going to use them again. So like I'm going to put that in there just so it's there in case I need it for more subqueries, because like we're going to write a couple of these. So for the user ID, I'm going to use that subquery. And then for the family ID, I'm going to actually write another one. So select family ID from family where name is equal to Gamgee house. Now that's probably isn't best practice just because normally we wouldn't want to add someone based on the name of the household, but we're doing it just so that way we don't have to worry about trying to keep track. So let's make sure this works. There we go. We're going to take this, put it in our CRUD statement here under our family, because this is for family member. But then also we have our family. This is our read, which is our select statement. And there we go. So you can kind of see how you put together these CRUD statements. And it works because you're going to have to fill in test data regardless. So I'm just going to kind of format some of this file here so it makes sense. That was our system user, family, and family member. So there we go. You can kind of see how that's working. Do you guys want me to kind of keep going? We're 10 minutes over. More than happy to kind of do a couple more if you think that it's helpful. But really, I guess before we end, what I want to do is why I'm saving these. So let's say I want to, let's add this before. So what's nice is now I can actually just come in here, delete everything, right? So now I'm back to a fresh, clean database as far as my stuff goes. So like, for example, if I go back here and say, oh, what are my system users? Well, there are none. So I can, based on these 3 files, I can basically wipe everything and recreate it very easily. So I have my schema. Let's just open the schema one. Open file. Open SQL script. There we go. Let's open this so we can actually see the file names here. And I want to use family cookbook. All right, so between all 3 of these, I can, let's put a use statement on all these just so we have it use. Family cookbook. All right, so based on all 3 of these, I can delete all the data and basically recreate it really nice and easily. So if I make a change to the data, I can truncate the tables, fix the tables, and repopulate the tables. Does that make sense to everybody? Anyone confused on that? Because otherwise, if you just use the model, let's say I were to just forward engineer here. If I were just to forward engineer here, I'm going to lose all my data unless I have that in a script somewhere. you're going to have to redo all your work. So what I would highly, highly recommend, because this has happened and I feel terrible every time, I would highly, highly recommend build your model and save your model. Make sure your .mwb file is backed up, but also save all your scripts, and whether you want to put those in a Git, put them on your Google Drive, whatever, make sure they're backed up. And then you can kind of use them like this, because if you just rely on the model, you're going to duplicate a lot of work. But if you kind of put it out like this in code, basically you don't have to worry about any of this. This will kind of take care of itself for the most part. You might make a slight change here or there, and you can always regenerate this file based on your model. But especially like your seed, your truncate, and stuff like that, make sure you keep that all kind of scripted, so then we can undo everything, redo it really easy. Like for example, if I want to all of a sudden, hey, I want to put sample data in my dev cookbook, all I have to do is switch the database and bam. Now my dev database has all the same data as my production one as far as sample data. So you can see it's really easy to kind of like drag and drop this script. And then what's nice is, let's say that you're going on a trip and you want to continue working on your database and have all this sample data. All you need is these 3 files, right? You just take these 3 files with you and you can create everything from scratch in about 3 seconds, right? As fast as it takes you to run those scripts. So anyways, I definitely wanted to show that to you guys because people are getting there already, which is awesome. If you have any questions about that, feel free to let me know. I'm more than happy to answer them. But does anyone else have any questions, last minute thoughts before we all go enjoy our evenings? All right. Well, I will let you guys go. I hope you guys have a great evening. Again, if anything comes up, just let me know. More than happy to help, and good luck this week.
Thank you.
Thank you.
Yep.
Thank you.
Thank you.